Hello friends, welcome to How to VLAN channel. This is DB VLAN stream. This is kind of an experimental video which I have never tested all through my career. I came across a scenario recently wherein every day exactly at 2:30 am in the morning I saw a flip in the memory utilization where there was a sudden drop in 50 GB of cache. Immediately there was a follow-up action where sudden swap activities increased and that resulted in an alert for me. So I needed to find out what happened and why is there is a swap space utilization. My assumption here is that the sudden drop in memory, when I say sudden drop in memory, sudden drop in cache, should have pushed the pages in physical memory to swap, and immediately that should have resulted in swapping activity. Here, the pages we are talking about is the SGA because I did not configure huge page in that particular platform for Oracle SGA. So we will really see in our test lab when we similarly drop the cache, what will happen? Come on friends, let's get into the video. As usual, the steps. First, we need to start our Oracle database server VM. Second, we need to start the DB and we need to perform the health checks. These are the health checks I normally do. And we are examining the composition of the SGA to see how exactly this is going to be influenced by the VM cache drop we are going to perform. And then we will examine the SGPG setting. It's already examined anyway. Memory distribution in Linux through free minus G command. Okay, or K, whatever you want to use. Better K so you get more granularity. And then initialize the monitoring VM stat 1020. It will tell you how much is in cache, how much is used, how much is free. When it comes to VM stat, it doesn't separate physical memory from swap. It takes them both of them together as one large memory footprint and classify them as used and unused free. And then we'll have all the alert logs tail, database alert log, voice messages and D messages. And we will drop the cache and then we will check the alert log again, check all the alert logs again. So all the logs for the impact assessment. So let's get started. Alright, let's get started. So I already got my virtual machine up and running. It's already up. And I already got my VM running and I already got my database up and running. You can see I already started the DB. It's already in rewrite mode. So now let's get started with our health check routine as we said. Let's examine the health of the DB. Let's find out this read write. Online and system data files are and the registry components are valid. The indexes in system are valid. So we are examining the composition of SG and PGA. SG max size is 1.5. I think I'm using memory target. Yeah, I'm not using AMM. I'm using ASMM only. Automatic segment space management. No. I'm using automatic. I'm not using automatic memory management. Okay. I'm using SG target and the SG max size. And PG is 500 MB. So 1.5 GB for the SG. PG is 500 MB. Totally 2 GB I have consumed. And how is my statistics looks here? WSG stat. Large pool is 16 MB only, shade pool 560 MB, stream pool 768 MB. Oh good. Then buffer cache is 159 MB. So this is already evaluated in last step. Let's not do a detailed study on subpools because If in case need, we can do it later, but not really now. Okay. Then next step is to evaluate the memory composition. Right. So free minus k. So if you see, there is 3 GB in buffer cache, 4 GB is the total memory allocated to the machine, and used it shows only 560, 590 MB. Yeah, and free is 164 MB. In the shared pool, it is 1.5 GB, which is shared or SGA, and buffer cache is 3.1 GB because it has file system cache 3.1 GB is, and available is 1.7. So if you sum up this shared and available, I guess you will get this buffer cache. So it's come close to 3.2 or something, but it's fine. So the buffer cache will be used whenever we need for any other purpose. All right, and yeah, swap is this much only. And the other way to know how much is my memory usage is, let's find out the PID of the PMOD. Oracle is using a shared SG only, isn't it? So even if you're on top, all the Oracle process should show up same amount of virtual memory or more or less the same. So if you see 2 GB, it shows 2 MB, I think that's virtual memory totally. And so slash cat slash proc will pick one of the PMON, the PID of the PMON. Easy to evaluate. And if you see here, there should be status. All right. You should see the memory composition. Now we will see everything, status and everything. Stat. Not this. Yes, this is the one. You can see here the VM peak memory is 2 GB. VM size is 2 GB. Virtual memory size. High watermark is 24 MB. So it's not really, I mean, yes, we asked for 1.5 GB, but Oracle never allocates 1.5 GB on the first place itself for the SG. It grows on as per its demand. Similarly, in the Postgres also the same way it happens. You may ask for some shared pool size, but it doesn't allocate the shared buffers immediately itself in the beginning itself. It takes time to warm up the memory, and it allocates them only when they need it. But huge page story is different. Huge page will pre-allocate the memory for you and keep it ready. Anyway, so let's go. So this is how it looks. So let's note down this command also, that we need to store it. Memory distribution. We'll say pmon PID. Okay, and it's already being monitored. If you see, I've already initiated the monitoring is ongoing, and I have the alert log tail here, OS messages tail here, and D messages tail here. So all these are already ready. All right. So let's go to the next step. So we got all this up and running. So the next step we have to do is drop the cache. I will do this as a root user. I want to see the time. All right, it's done. So what has happened? Alert log did not show anything. That voice message show anything? 2325. It's 232503. Yes, there was one message. Drop 3. Voice messages. Okay, D message. What is it? So it did not show anything. There was one message, one command fire, drop 3, drop cache 3. Okay, but VM start shows the action. Perfect. You see here, I'll cancel this here. You can see here how huge is the difference. See, the cache is completely dropped. It was 3.1 GB cache before. Now it is 733 megabytes. Wow. So it does. In that particular moment, we had user CPU 1%, system CPU went to 31, idle 68, wait done, okay. Nothing has changed, but it's warming up again. You see, 732 it was, and it's now warming up again. And there's a lot of IO activities happening. Let's leave it, and it's keep increasing. You can see here. You see, it became 1 GB now. It keeps increasing 1.12, 1.2 GB, 1.25 GB. Oh my god, it's warming up. Hmm. If I run this command again, has it made any difference in the VM peak? Nothing changed, really. All right, and yeah, swap is completely used, guys. This is what I really saw. No, it is free, is it? Oh, okay. So swap never is used. Used is still 500 MB, but free is 2 GB now. Alright, it never dropped the used space, but it dropped the cache. It dropped the file system cache. Alright, so what was available before we saw? This is how it was looking before the drop cache command was fired. So after now, I mean, it's not immediately, but after some time, yes, it's already started building the cache again. The cache is dropped. In the shade size 1.5 GB, it is 600 MB. Hmm. We had an impact on the shade area as well. Anyway, the shade area never went below the used space. You see, the used space was very much constant. Only the free increased. But I don't see any swap activity though. Which I was looking to see if there may be an increase in the swapping. Because I thought the pages will be pushed to the swap. But it didn't happen that way. It didn't happen that way. Okay, anyway, let's go back to the steps. So we saw not much difference in terms of the voice messages or right. I think these messages are always coming. Nothing need to be aware about it. Yeah, but database did not show even a single alert during this window. So what really happened is it dropped only the file system cache. It didn't drop the database SGA. Hmm. Because we didn't see any difference in the memory that was allocated to the Oracle process. Before and after it was still the same. And the file system cache is getting very much warmed up. You see it's constantly growing. Fine. As soon as I start accessing something, I think it will start growing very huge. can see the cache is increasing with each time I'm running a command. Alright, this is what I wanted to see, guys. So I really observed it. Alright, summarization. First observation. What is it? The cache drop. Alright, we need to check the health of the DB, isn't it? We need to do one more evaluation. In the DB, did it make any difference? Read write online system. Valid option of valid 1.5 GB, SC target 1.5 GB. Okay. PGA 500 MB. Okay. What was our value before the cache drop? Memory composition before and after. Let's check that. Before, this is how it was consumed. After, I don't think any changes are there. Yeah, nothing changed. Alright. Cache is just building up. Let's keep increasing. Freeze declining and cache is increasing. Alright, this is the main thing we wanted to check, and we will check the alert log once. Sorry, DB health once to be sure that we are looking good. Oh, we already evaluated. Okay. Nothing changed. I think the Oracle SSD is never moved out of the memory. But because there was no memory pressure. There was no memory pressure. So it never had to move. Swap never increased. Versus what I am observing in a real life scenario where I saw swap activity. But here there is no swap activity. But everything else matched. We got everything. Cache did not. The cache drop did not interrupt Oracle DB because we didn't have any load on the DB. And maybe if I had run a query with a large amount of temp space usage, it might have made a difference, I guess. All right. And then the cache drop resulted in file system cache being dropped and rebuilt. No swap activity observed. VM start showed the evidence. I'll plot the graph for the VM start and I'll show you guys in a graph pattern. That may help you. Apart from that, we saw the free minus G differences. Free minus K difference in Oracle, the memory footprint never changed anything. And Oracle's per process memory did not change anything. Process base did not change. And the cache was dropped. There was a sudden rise in system CPU usage. Alright, this is a symptom. Alright, thanks everyone. I hope you find this video also useful. Um, you can add your suggestions if you want me to make this test much more wider and much more complicated, and if anything else you specifically wanted to observe in the test, please feel free to add it in the comment section. I'll take a look. But for me, this is the real scenario I wanted to test, but I will add more complexities like running a query which will take away a lot of PGA. So when PGA starts consuming, you will see more stress on the memory. At that time, we may try dropping the file system cache and see what happens, because unlike SGA, PGA is a process memory. Is not going to stay forever. It's only for the duration of the process this memory will be allocated and left. So maybe I'll add that complexity further, and maybe I'll make another video. But I think this video really helped, at least for me. If it does for you, please give me a suggestion. If you have any suggestions to improve my video, please let me know. Or if you really like this video, if it helped you with something in terms of your learning, give me a thumbs up and subscribe to How to Learn channel. And please share it with your friends. And we'll be meet in the next video. Thank you. Thank you, everyone. All right. I told you guys that I will make an addendum to the video, or I'll show you the chart also, isn't it? So this is the chart. You can see here 23, 25, 03 is when this graph went down, this graph went up. This is when the cache dropped. So free memory increased, used memory decreased. So this is used memory, which is cache, and this is free. So the free increased and cache dropped. And you see here again the cache is increasing and the free is decreasing. And you see when the cache is increasing, there is an IO activity on the machine, which means that we started reading files from the file system, which they need to put it in the memory before you read it. When that IO increased, automatically the cache increased and the free memory decreased. And you can see here when this activity was introduced, there was a CPU choke. For a moment, the machine panicked, we can say, because the free CPU, idle CPU completely went down to zero. User CPU becomes 60, and system and IO weights were nearly equal, 2020, something like that. So, and the window that we are mainly looking at is 23, 26. This is the window. This is the window of panic attack. So 23, 26, 02, isn't it? So yeah, not this. Yeah, here 23, 25, 04 is when we created a panic, and it had an impact at a 1 minute later. You see there is a large amount of IO, and here is the actual window where there is the idle utilization becomes 0 or 1, and the CPU utilization on the user side and system side were all very high, and there is an IO weight also observed during that window. But after that, the machine got pretty much relaxed. I don't I don't see any issues right now. I think it's pretty normal, but still the cache is not completely warmed up. So the cache is still not completely warmed up. So earlier we saw 3.1 GB, something like that, right? So now it's still 1.4 only. So this is the addendum I wanted to add, guys. Thank you for staying with me again. Like I said again, I learned something from this video. If it does add value to your learning also, please feel free to share me feedback on the comment section. Thank you. Bye.